Right, notes on 7.7, solving right triangles. We see it in our title, and so right away we define what it means to solve a triangle. Solving a right triangle means to find all the angles and all the side lengths. So how many answers is that? 6. 3 angle measurements and 3 side lengths. Now, at first when you're like, wow, that's going to be a long problem, that's a lot of things to find out, we need to stop and think about how many we know to start with, okay? Number one, you are going to solve a right triangle. So if it's a right triangle, you have to have a right angle. There's one of our 6 things. And then right underneath it, that vocab, I said you must have at least 2 more pieces. Okay, so 2 more things, either angles or sides. And one of them must always be a side. If you think of your SOHCAHTOA, opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. Every time you have 2 sides there, we need to fill in at least one of them, or else we can't do the problem, okay? So we actually get started every time with 3 of our 6 answers. If they don't start you with 3, you can't find the rest, okay? So it's so important to realize we start with 3, and our job then is to find the rest, which usually is another 3, okay? So some things we need to go over here. We've started SOHCAHTOA. It's been making sense to us, but we need to remember that we haven't solved for any angles yet. We've just been solving for sides. So one thing that's super important to remember in math is everything in math has an opposite operation. I can add 5, and then I can subtract 5 to undo it. I can multiply by 7, and then I can divide by 7 to undo it. I can square something, or I can take the square root to undo it. I can do the cube of something, and then I can do the cubed root to undo it. So everything in math has something that undoes it. So we're working with SOHCAHTOA. We know that we have, like, I have it down here in the side. I have sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle equals opposite over adjacent. There's my SOHCAHTOA. But the question is if I want to get that angle all by itself, how do I move the sine or the cosine or the tangent off of it? And what we do to undo a sine or a cosine or tangent, we take what we call the inverse. So I write it like this, sine -1. And what I do to one side, I have to do to the other, okay? And on this side, a sine inverse with a sine cancel each other out, and I'm left with theta. Then on the other side, I have sine inverse of the opposite over the hypotenuse, whatever that number or fraction or decimal happens to be. So on all of these, the inverse is the opposite, okay? Now, this is so very important that I need to make sure you understand this, okay? I'm trying to make sure I get as much of my screen as I can here. You use an inverse to solve for a missing angle. You don't ever find a side with it. You only find a missing angle with the inverse, okay? So the inverse is always going to find you a missing angle. Okay, so this inverse trig box over here, it's just saying the inverse of tangent, the inverse of sine, the inverse of cosine. They can help you find the missing angle. Okay, so let's go ahead and use this right away. By the way, we need our calculators, and we need them in degree mode. Okay, so make sure you have this, and this is so important if you're using a calculator at home. You've got to know your menus. You've got to know what you have. If you're using your phone, you have to know, can I find this? What mode am I in? Can I find these inverse buttons, okay? Which, by the way, if you're using my calculator in class, just look above your sine, cosine, and tangent buttons, and in blue there is sine inverse, cosine inverse, tangent inverse, okay? So they're there, okay? So if I'm using my calculator at home, I have sine, cosine, tangent, and I'm trying to see, I'm just peeking at my own right now. You know what, if you hit, at least on my smartphone, if you hit the second button, it's over underneath on the left-hand side, far left, it says second. If you hit that, then all of a sudden you see the sine inverse, cosine inverse, tangent inverse. So I know on my phone, I can do that if that's the kind of calculator you're using at home. So very important that you get yourself familiar with the calculator you're going to be able to use on the test or quiz, because face it, that's in my classroom. I'm not letting you use your phone, but you need to know how to use mine in my classroom or the one you carry to school, okay? So make sure you know how to use your calculator. All right, so use a calculator to approximate the measure of angle A to the nearest tenth of a degree. I go to A, and just like I did in 7.6, I just start saying SOHCAHTOA, what do I have? So from A, right now, I see a 16, and that's opposite my A. Looks like my hypotenuse has nothing. Then I see 20, which is adjacent. So the two pieces of information I have are the opposite and adjacent. Am I going to SOHCAH or TOA that one? That's a TOA. Okay, so I'm going to set it up, tangent of my angle, always the angle. This time I don't have a number to put in, so I'm just going to put in A, but I need an angle there, equals the opposite, that's the 16, over the adjacent, that's 20. Okay? Now, I look and I'm trying to solve for A. Well, what's still connected to A? Tangent. If I want to get the tangent off of A, I need to take the inverse tangent. That's what undoes it. Okay, inverse tangent. These two cancel, and I'm left with A. Over here, I get inverse tangent of this whole fraction, 16 over 20. Okay. If you're using my classroom calculator, this is the time we grab it, check for it's in degree mode. We do inverse tangent, so I use the second button there. And I do, when it gives me in parentheses, I say 16 divided by 20. Don't try to do a fraction, 16 divided by 20, and I hit equals. And it tells me my angle is about 38 point, it says tenth of a degree, so 38.7 degrees, okay? All right, so let's kind of talk about what this is doing. Okay, one thing, remember when we just set up our tangents and we set up our sines and cosines, and I said put, you know, your hypotenuse, your opposite over your hypotenuse. Okay, now turn it into a decimal for 4 decimal places. Well, we can do that with that 16 to 20. I do 16 to 20 and I get 0.8, so I get 0.8, always 4 decimal places, so I put it down to 4 in inverse tangent. Okay. What we're doing is we're asking our calculator what angle had that ratio of 0.8880000, and it told me 38.7. Okay, the other thing you can do, and it's not super accurate, but it works. If you go to the back of your books, okay, and on page, and of course I'm going to forget what page it was on, 925, page 925, there's a big chart there of all your sines, cosines, tangents. So I can go look, and on my big chart, in fact, look, I have the chart right here. If I go to tangent, which is, just so you know, it's the far right hand, see it's these right hand numbers right here. These are the tangents, okay? And I'm looking for where that decimal is really close to 0.800, okay? So not yet, but I'm definitely in this column. And look, by the bottom of the page, I'm at 1. So I think 0.800, it's going to come right in between these two decimals here. So it's right in between 38 and 39. Oh yeah, what did my calculator just tell me? 38.7. So your calculator has this chart already in it. It's a big computer, right? It already knows this chart, but it knows the chart even better than our books gives it to us because it knows all the in-between decimals as well. So it's just finding where that ratio matches, and it goes to the angle, and this time it's 38.7. Okay, so that's what we're finding is we're taking that ratio we know about, and we're asking what kind of angle has that ratio. Okay, the nice thing is, though, if you have your calculator, you don't have to worry about the chart. You just plug in the right thing and make sure you use the inverse when you're finding a missing angle. Number 1, in example 1, use a calculator and an inverse tangent to approximate the measure of angle C to the nearest tenth. Okay, so just so we can kind of see what's going on here, here's angle C at the top, okay? A was down here. I still have a 16 and I still have a 20. Okay, so I'm going for angle C. Well, from C, here's my hypotenuse, I don't know it. Closest one is adjacent. The one across is opposite. So once again, I know an O and an A, so I'm thinking TOA. So I'm going to say the tangent of angle C this time, because that's what I'm looking for. Its opposite is 20. Its adjacent is 16. Now, we're solving for C. What's connected to C? The tangent. How do I undo tangent? I take the tangent inverse. What do I do to one side? I have to do to the other. These two cancel, and I get C equals, always put the tangent inverse first, and then over of 20 over 16. Okay, I'm going to my calculator. I'm ready for that. So make sure I use that second button so I see tangent with a little -1. And 20 over 16, use a division bar in there. And I get C is an angle of about 51.3 degrees. Okay. Do my answers make sense? This one's 51.3, right? This one over here was 38.7. What's 51.3 plus 38.7 plus 90? 180. That makes sense. So my two angles I found, they add up to 180 with their 90. Is my biggest side across from my biggest angle? Well, the 90, right? We don't know that one. But how about on the two shorter sides? 20's across from 51.3, 16's across from 38.7. The longer side's across from the bigger angle. Works for me. All right, so let's move to page 2 here. Okay. I like these top two questions because they're so incredibly easy, but I am going to tell you so many people miss them on my test and quiz because we freeze and we don't know what we're doing, or we didn't listen to this video, or we didn't pay that close of attention, and we look at them when I give them to you on a test and quiz, and you're like, what do we do? Okay. So number one, I know I have this chart on the page. So if you're doing your homework tonight and you can't find a calculator somewhere that has SOHCAHTOA or inverses on it, you can use the chart to get a good estimate. It's not going to give you the exact decimal, but you can make a good guess like, hey, it's between 40 and 41 and it's closer to 41. So, you know, I'm going to make it 40.7, something like that. You could make a good estimate. But that chart's there, so you can't tell me I couldn't do my homework at all. But what this is saying right here is, in question A, it says sine of A equals 0.76. So I could go to my chart and I could find a sine. So sine is in this, let me change my color so you can see this. Sine is in this column, right? And I'm looking for something 0.76. Not there yet. In fact, when I look over here, I'm not quite, I hit it about right there, right? So I'm about 0.76, about right there. So I'm thinking right around 50 degrees, right? Okay, let's go back to our page and let's go here. Remember, if I'm solving for A, how do I get that sine off of it? I take the sine inverse, okay? So sine inverse cancels, and I get the sine inverse of 0.76. This is straight up calculator work. I can't even do anything myself. So I need to use my calculator. Inverse sine of 0.76, and you can plug in a decimal instead of a fraction, not a problem. And I get 49.46. That's pretty close to that 50 degrees that I just found on my chart, isn't it? Notice they said to the nearest tenth, so I rounded up to the nearest tenth there, to 0.5. Okay? So the same thing over here with B. I see cosine of B equals 0.17. If I want to solve for B, I ask myself, how can I get B by itself? Well, right now it's connected to cosine. How do I undo cosine? I take the cosine inverse, and what I do to one side, I do to the other side. These two cancel, and the measure of angle B is going to be the cosine inverse of 0.17. So on my calculator, inverse cosine of 0.17, and I get about 80.2 degrees. Okay. Now, I'm going to bring back something real quick. If you remember from our sine and cosine notes, we were right in the ratio of a bunch of these sines and cosines at different angles. And I told you to look at the decimals they always gave. One of the things we said is the decimals we always got were smaller than 1. None of the decimals were ever bigger than 1. They were always 0 point something. So quick note, they should be that. So if you see a decimal that you're trying to take the inverse of and it's not 0 point something, your calculator is going to give you an error, okay? So make sure you're doing your math correctly because you should have a decimal that's smaller than 1 or a fraction that's smaller than 1 with a sine or a cosine, or you will not be able to get the answer with the calculator. Okay. Let's move on to our next example. And to be honest, I mean, I could give you 5 of these and it makes me know if you know the lesson or not, okay? So what we're doing here on example 3 is we're going to solve the triangle. So I gave you a quick reminder in the margin. What's it mean to solve a triangle? Find the measure of all 3 angles to the nearest tenth. Find the side length of all 3 sides to the nearest tenth. Now, that's the rule I'm giving you right now is nearest tenth. If I change it, I'll make sure I tell you. Okay, so that's our job right now. So before I even start, you know what I'm going to do? I'm going to write down the measure of angle A, the measure of angle B, the measure of angle C, because those are the three angles I need. And then I need side AB, side BC, and side AC. Okay, those are my three sides. Okay, don't forget, how many do I already know? Three. They always start me with three, so let's think. Okay, angle A is 23. Oh, I don't know angle B. Angle C is 90. And side AB is 40 feet. Okay, I know three of them right away before I start. Okay, my job now is to find the rest of them. Heads up. Probably the easiest one right now is angle B. How can I find angle B? Well, if I know two angles, I can do for angle B, I know that 180 is the whole triangle, and I'm going to subtract that 90 and that 23 I already have. All right, so 180 minus the 90 and the 23 gives me 67. Okay. Well, that was kind of easy for my angles, okay? Now I'm missing two sides. Okay, heads up. Do not use an inverse to find a side. You can't do that. Inverses only find angles. We already know all of our angles. We're not using an inverse on this problem. Okay, we have two sides to go. I am going to call BC my x, okay, just so I can put it there. So I know this angle of 23. Where is x over here? Well, it's opposite. What else do I already know? The hypotenuse over here. Okay, so think about this. We have SOHCAHTOA. I'm looking for the opposite. I have the hypotenuse. Which one am I using? Aha, so. All right, so I'm going to do the sine. That's what S stands for. What's my angle? Up, it has a number, so I'm going to put it in there. Sine of 23 equals, what's my opposite? I just marked it X. What's my hypotenuse? 40. All right, it's algebra time. How do I get X by itself? Well, right now I'm dividing by 40, so I'm going to times by 40. Undo that 40 to get it to the other side. What I do to one side, I do to the other. These two cancel. On this side, I have 40 times the sine of 23 degrees. That is my standardized test answer. It is time to go to my calculator. 40 times the sine of 23 degrees. 15.6. All right, so I get about 15.6 there. Okay. Next part, though, which, by the way, I should write that down, right? Okay, I'm just going to lift my picture just slightly. Okay, so this one is about 15.6. I have one more to go down there at the bottom. Now, once I know two sides of a triangle, I can use Pythagorean theorem to find the other one. But I'm going to tell you again, trigonometry is faster than Pythagorean theorem. I prefer, because I know this 23 and this y is adjacent, and I know my hypotenuse, I'm going to use an adjacent hypotenuse and do a ka. So I'm going to have the cosine of 23 degrees equals my adjacent, which is y, over my hypotenuse, which is 40. Okay, I have to get y by itself. So right now it's being divided by 40. I'm going to multiply both sides by 40. All right. And I'm going to get 40 times cosine 23. All right, that's my standardized test answer. I hit that on my calculator, and I get 36.8. Okay. So let me come label that up here, 36.8. That was my y, and I got 36.8. I'm going to put it up here. Okay, quick reminder, that angle up there was 67. So, did I solve my triangle? Yes, I have all 6 answers. Now I'm just trying to make sure it makes sense, right? So I'm looking across from each other. 90 is the biggest, and it's across from the 40. Yep, 40 is my biggest side. That's good, right? Then I look again, and I go, oh, my smallest is 23. I have 15.6. Yep, that's smaller than 36.8 and 40. So it's making sense. My medium angle is 67. My medium side across from it's 36.8. My answers make sense, so I'm feeling good on it, and I'm fine to move on, okay? So always check to see if it makes sense. Okay, so let's move to the last page, okay? And let's look up here at the top. It says, You're building a track for a model train. You want the track to incline from the first level to the second level, 4 inches higher and 96 inches. Is the angle of elevation less than 3 degrees? For those of you that work with a model train, you know if you get that track too steep, the train doesn't have the power to get up it. So in this particular occasion, with this train, we must need to keep the train track in an angle of elevation less than 3 degrees, or else we won't be able to get that train up the track. So it's important to say, here's how long I have, here's my inches, can I keep that angle under 3 degrees? Okay, so I have a nice right triangle. I'm looking for this angle over here. I know the measure across, or opposite, is 4. My hypotenuse is the one up here where the train will go, and so my adjacent over here is 96. All right, O and A, that must be TOA. So I'm going to use tangent. Tangent of angle x equals the opposite, which is 4, divided by the adjacent, which is 96. Okay, remember, this time I'm solving for an angle, and when I need an angle, I use the inverse. Okay, x is what I'm solving for. Right now it has tangent connected to it. How do I get the tangent off of it? Well, I do the opposite, which is the tangent inverse. What I do to one side, I do to the other. So x is going to equal the tangent inverse of 4 over 96, okay? Now, remember, you can leave it a fraction just like it is, or if you change it to a decimal, 4 decimal places for that decimal, okay? I'm going to leave it where it is and take the inverse tangent of 4 divided by 96, and I get about 2.4 degrees. Okay. That angle's 2.4 degrees. That's pretty small. It's 2.4 degrees. Is it less than 3 degrees? It is. So does that mean I can drive that train up there? I can, right? Is that a practical problem? Sure it is, because if you're building that model, you need to know how long do you need to make that incline so your angle's small enough. All right, number 2 here. Easy question if you remember what it's asking. Sine of D equals 0.48. I'm solving for D. So ask yourself, how do I get D by itself? Right now it has sine connected to it. To get rid of sine, I need to take the sine inverse. What I do to one side, I do to the other side. These two cancel. D is going to be the sine inverse of 0.48. And so I'm taking the inverse sine here of 0.48. And I get about 28.7. 28.7 degrees. All right, number 3, solve a right triangle that has a 50-degree angle and a 15-inch hypotenuse. Okay, always best to draw my picture. And remember, if I'm solving it, I need to find everything out about it. So here's my triangle. I have a 50-degree angle, 15-inch hypotenuse. Well, the hypotenuse has to go here. Does it matter now where I put my 50-degree angle? No, because I don't have enough information. Okay, so there's what I know. By the way, I am going to name this ABC just because I want to make sure I can label it and go there. Okay, I'm solving it, which means I need to know the measure of angle A, the measure of angle B, the measure of angle C. I need to know side AB, I need to know side BC, and I need to know side AC. How many do I already know? I know my angle B is 90 degrees. I know my angle C is 50 degrees. I know my side AC is 15 inches. Okay, remember, you should always know 3 at least. Maybe they'll be nice and give you more. Okay, first one that's probably the easiest is angle A. I know for angle A that all my angles add up to 180. So if I subtract my 90 and my 50, I get 40 degrees. Okay. So angle A is 40. I'm done with all my angles. All right, time for some sides. I'm going to make AB over here X. Well, from the 50 I start with, X is opposite. The other thing they gave me, though, was the hypotenuse. So if I have a little O and H, so. So I'm going to say the sine of 50 equals my opposite, which is X, over my hypotenuse, which is 15. I want to get X by itself. What's connected to X right now? the 15. It's being divided by 15. How do I undo 15? I multiply by 15. What I do to one side, I do to the other. This side, it cancels. I'm going to get 15 times the sine of 50 equals x. Run that through my calculator, and I get a side of about 11.5. All right, so I get 11.5 over here for AB. All right, am I done? Nope, I have one more side to go. I'm getting a lot of red and I'm getting confused. Okay, I'm still going to go, I need this side BC. I like my 50-degree angle, and this y is adjacent, and they still gave me this nice pretty number as a hypotenuse. I'd rather not use that 11.5 I just found. You can, but I'd rather stick to what I know. Okay, so I have an this time. I'm going to come up here where I have some room. Is ka. So the cosine of what angle am I working with? 50 equals the adjacent, which is y, over the hypotenuse, which is 15. All right, I want to get y by itself. What's connected to y? The 15. How's it connected? By division. What undoes division? Multiplication. So I'm going to multiply both sides by 15 so it gets off that y. Multiply by 15 and divide by 15 cancel. Y is by itself. I get 15 times the cosine of 50. That's my standardized test answer. Run it through your calculator. 15 times the cosine of 50, I'm getting about 9.6 on that y. All right. Now, on my picture, it seems that that should be longer. But remember, it's about the numbers, not about the picture. And everybody knows I'm a terrible artist. Okay. Across from the 50 is 11.5. Across from the 40 is 9.6. That's good, because the bigger one's across from the bigger and the smaller is across from the smaller. So even though my picture isn't drawn to scale, our numbers make sense. Okay, did we solve that triangle? Yes, we have 6 answers, 3 angles and 3 sides. All right, in example 4, up there at the train, suppose you have another incline and you rise 8 inches in 120 inches. So draw that. So in 120 inches long, I go up 8 inches. Okay. Is the incline less than 3 degrees? So here's my angle again. This is the incline, and I want to find this. So I'm going to put an X right there. Okay. So from my angle that I'm looking for, I know this one that is opposite, and my hypotenuse is here, it's unmarked. And the leg that's touching is the adjacent. Okay, O and A. O, TOA. Okay, TOA is a tangent. Tangent of my angle X equals my opposite, which is 8, and my adjacent, which is 120. What's my variable? X. Okay, what's connected to X right now? The tangent. How do I get rid of a tangent? I take the inverse tangent. What I do to one side, I do to the other. These two cancel. I'm left with X equals inverse tangent of 8 over 120. All right, calculator time. Inverse tangent. If you're going to turn 8 divided by 120 into a decimal, make sure you leave it in 4 decimal places. So here X is going to be about 3.8 degrees. Okay. Is that incline less than 3 degrees? No. So that train might not make it up if I try to do that one that's 120 inches long and 8 inches high. All right. Solving a triangle means all 6 answers. If you're finding just a side, you use your SOHCAHTOA just like you've been learning before, or you can use Pythagorean theorem. If you're looking for an angle and you can't subtract 2 angles from 180, you must use the inverse of a sine, cosine, or tangent. Okay? Now, your homework today. I do not have you working in the book. It got too confusing. So you do have a worksheet. Okay? Look for your 7.7 worksheet. Please show your work. Please show your setup so we can check to see, did you use a sine, cosine, or tangent? Did you use an inverse, or did you try not to use an inverse? And that's where we're going to be able to tell where the problems are. So you've got to show your work. Let me know if you have any questions.